Okay, this is our warm-up for section 8.2. You should have already watched the video. Pause the video and try these problems on your own first. So in the last night's video, you learned about arithmetic sequences. And yes, I know it's spelled like arithmetic, but it's pronounced arithmetic when we're talking about sequences and series. And an arithmetic sequence or series is when the jump from one number to the next is adding or subtracting the same thing. So in example 1, it's subtracting 3, and then subtracting 3, and then subtracting 3. So it's adding -3 every single time. That number that it's adding is d, and it also represents the slope. Because in arithmetic sequence, the dots are linear, but it is discrete, right? We're not connecting the dots because n, because our x-axis is n, cannot equal 1.5. So we can't connect the dots between those two values. So we jump to just the whole number n values. But it still has a slope, which is represented by d. So a sub n is going to be -3n. And then you can just look at it and figure it out, right? If this is n equals 1, because that's my first term, if I plug in 1 here, -3 times 1 is -3, plus something has to equal 10. So you can just figure it out that way. Or if you take it a step backwards, so undo it, so add 3 to your n equals 0 term. If I add 3, that means the number right before it would have been 13. So 13 would have been your y-intercept. So 13 goes at the end of our equation. Okay, example 2, I've given you A1 and D. So let's just start by listing out the sequence. A1, and then it's adding 5, so plus 5, plus 5, plus 5. You get the idea. So we know our sequence A sub n is going to be, it's adding 5 each time, 5n. If I undo that one step, go backwards, minus 5, our b value, our y-intercept, would be -2. -5n minus, 5n minus 2. Okay, number 3. I didn't give you the first term this time. I give you the second term is -2. Gap. The fourth term is -10. And I do realize these terms are relatively close to each other, but we don't want to just rely on that in order to figure out how to do these problems, because what if they're further away from each other and not so close to the beginning of the sequence on the test? So instead, we know that it is d is the slope, which we know is rise over run. That's one way we've learned to talk about slope. It's also change in y over change in x. That's a little triangle, a little delta symbol. It means change in, so change in y over change in x. So if I look at the y values, right, that's the sequence the sequence value, and I find the difference between them. So from -2 minus -10, and then I look at the n values, which are equivalent for x's in this problem. 2 minus 4. I'm kind of crushing myself up there. So that's going to be -2 plus 10 is going to be 8. 2 minus 4 is going to be -2. That's got an m value, a slope value of -4. So now I know my sequence is -4n plus something. Well, now that I know half of my variables, d and b are my variables, now I can use something I already know to figure out what the answer to b should be. So when n equals 2, my answer should be -2. So when n equals 2, -4 times 2 plus b, it should equal -2, because that's what my sequence equals up at the top. I shouldn't have written this part. So -8 plus b equals -2. Add the 8. B is going to equal 6. So a sub n equals -4n plus 6. And then we should always check it out. Plug in 4. -16 plus 6 does make -10. So since I knew it worked over here, and then I checked it over there, that's our answer. So just to be clear there, you find the slope by subtracting the y's and subtracting the x. So change in y means y1. So that's another way you might have learned this. y1 minus y2 over x1 minus x2. It doesn't matter if you do the first or the second as long as they match. So I could do negative 10 minus 2 as long as I do 4 minus 2, right? Do it in the same order. Once you know the slope, you know half the equation. Plug in one of the things you know needs to be true to find the other part of the equation. Number 4 you couldn't see before. Copy down number 4. Now we're on to sum. Arithmetic sequences have a nice little formula. I showed you kind of why the formula works in the video last night. But just in general, we're going to need to know A1, the first term that they're talking about, AN, the last term that they're talking about, and N. So find the sum of the first 20 positive integers. So when all else fails, make a list of what they're talking about. So 1 plus 2 plus 3 plus 4 plus ... The first 20 positive integers, hopefully it's clear that's going to stop at 20. So A1 is 1. The last term they care about is 20. And if I'm adding up the numbers from 1 to 20, how many numbers do I have? I have 20 numbers. So the sum is going to be 20 numbers. So I want you to be clear, this one comes from this one, where I add the first number plus the last number, but then I divide it all by 2. So this reduces to be 10 times 21, 210. Would be the sum. If you added all the numbers from 1 to 20, you would get an answer of 210. There's number 5. Copy number 5 down. Try number 5. Pause the video. Find the sum of this sequence to n equals 12. So if we look at the sequence, minus 3, minus 3, I'm doing sum of an arithmetic sequence, so I know the first term, I need to know the last term, and I need to know how many terms. So the first term is given. It says I'm adding up to the 12th term, but I need to know the last term. I need to know the 12th term. So to do that, I need to know what this sequence is, the equation of the sequence. So they're subtracting 3 every time. Negative 3n. If I undo that one step and plus 3, it would have been plus 1. So double check that, like, 1, 2, 3. If you plug in 3, negative 3 times 3 is 9, plus 1 is negative 8. So it is the right sequence. So then if I want to know the 12th term, plug in 12. Negative 36 plus 1 is going to be negative 35. Then use your formula. The sum is equal to 12 numbers, the first number plus the last number, divided by 2. So this reduces to be 6. 6 times negative 37. Not terrible to ask you to do one test day. You'd get negative 222. Okay, last 2 problems. Copy them down, pause the video, and try these on your own. So arithmetic sequences, sigma means sum it up. So arithmetic, because this looks like the equation of a line, it's a linear equation. Both of these are linear. Arithmetic sequences, I need to know the first term, the last term, and how many terms I am adding up. The index tells you what to plug in to get your first term. So I'm going to plug in 1. Negative 2 times 1 minus 3 is negative 5. The index tells you what to plug in to get your last term. So I'm going to plug in 15. Negative 2 times 15 is negative 30. Minus 3 is negative 33. And then if I'm counting from 1 to 15, how many numbers do I actually hit? I hit 15 minus 1, but then plus 1, right? I hit 15 numbers. Don't forget to add 1 when you're trying to do the sequence, which when it starts at 1, that makes sense, but we get to number 7, that's when people mess up. So then S is equal to the number of terms, the first term plus the last term, divided by 2. This one doesn't work out as easily to try to reduce by hand. This is 15 times negative 38 divided by 2. Negative 38 divided by 2 is negative 19. 15 times negative 19 ends up being negative 285. Try 7 if you haven't yet. First term, last term, number of terms. Plug in the bottom, which is a 5 this time. So plug in 5. 15 minus 4 is 11. Plug in the top, which is 19. 3 times 19 minus 4 gives you 53. And then top minus bottom, but then plus one more. It's always one more than you think. Count it out on your fingers if you need to. 19 minus 5 plus 1 is going to give me 15 numbers that I am adding up. The sum is 15, the first term plus the last term, divided by 2. 15, 64, divided by 2. That's 32. 15 times 32. I mean, not terrible, but you can also use a calculator when you're in class. 480 would be the sum for number 7. Okay, I hope this helps. I hope you guys are doing well.